Hey, sixth graders, today we are starting an assignment that I kind of am really excited about because we've been talking about how we're going to be putting together all the different little pieces of the puzzle that we've been learning over the last several weeks on ratios, equivalent ratios, on rates, on how to calculate a unit rate, on proportions, all of those things we're putting together in this lesson, and then being able to do something fun with tables and with graphs as well. And so today, this is over lesson 8.2. And I've already told you, but I wanted to remind you that you're going to have to remember how to find an equivalent ratio and a unit rate to complete these problems. And I know that you guys will be able to do that. One other thing that I want to make sure that you remember from lesson 8.1 is the difference in appearance between an additive and a multiplicative relationship. We talked in depth about those and to see how they would be different, how they would change, and different things like that. And the one thing that I want you to be aware of and to remember on any test that you may take, if they give you a coordinate plane and they have a line drawn and they ask you to describe the relationship, I want you to remember that additive relationships will never, they do not ever cross through the point of origin. And the point of origin is the point 0, 0. Multiplicative relationships, however, they do pass through the point of origin. So if you plot points and you draw a line and you connect the dots by drawing a complete line with a ruler, you should go through the point of origin to prove that you have a multiplicative relationship. So let's get started with the lesson, and then I'm going to go through some different steps with you guys shortly. This is what your book looks like, and this is where it shows us that we're going to be using ratios, rates, tables, and graphs. So without further ado, let's jump into it. The first assignment, or the first, problem that we're going to be looking at deals with a science issue. And you guys are familiar with what you do with our science teacher here. You know what a solvent is, and you know what a solution is. But in case you have forgotten, when you have water and you put a solvent in it, like sugar or salt, the sugar and salt can completely dissolve in the water to where it still looks just like water, but it changes its taste, right? Okay, well, this is an experiment where they're doing that very thing. This says the students in Mr. Webster's science classes are doing an experiment that requires 250 milliliters of distilled water for every 5 mils of solvent. The table shows the amount of distilled water needed for various amounts of solvent. And a really good question that one of your classmates asked is, why are they inconsistent in the table? Why do they go from 2 to 3, then 3.5? Why don't they do other 0.5s? And the only explanation that I could give him is that it's asking for various amounts. It doesn't ask for consistency there. But if you look and you remember what we've talked about in class, your top row is always your X. Your bottom row is always your Y. And I need you to remember the reason why this is that we won't know how much water we're going to need to have until we know how much solvent we're starting off with. So the water is dependent upon the solvent. Now let's start going through A through E. A helps us start breaking down all the different steps that you're going to have to do to solve these problems. It says use the numbers in the first column of the table to write a ratio of distilled water to solvent. Now the first thing I want you to see is it's asking for us to use these first two sets of numbers. But it asks for a ratio. Y'all remember that there are 3 different ways to write a ratio: fraction form, symbol form, and word form. Well, today you're going to see me do all of them in fraction form because we're going to be transferring them into rates and unit rates. So if we start off in fractions, we don't have to adjust them anymore, okay? And it asks for distilled water first, but isn't it kind of odd that they do that? Because distilled water is our Y. but nonetheless, that's what they've asked for, so that's what we'll give them. So we're going to put a 100 on top, and that is distilled water, and I am going to put H2O as my label since both of them are in milliliters. I don't want us to get our labels mixed up. And our bottom number is going to be 2, and I'm going to use an S for solvent. That's our ratio of distilled water to solvent based upon our table. Now B asks us a unique question. How much distilled water is used for 1 milliliter of solvent? That's a quick, instant reminder, guys, we're solving for our unit rate. And you've learned to do that by setting things up as a proportion. So let's take our original rate from the table. That would be 100 mils of water over 2 mils of solvent, and we've got to figure out how much water we're going to use with 1 mil of solvent. We're going from a big number down to a little number, so we're dividing, and we're going to have to divide by 2. That means we're going to have to do the same thing to the top, which 100 divided by 2 is 50. So our unit rate is 50 mils of water to 1 mil of solvent. Now I'm going to do something weird. I'm going to go back up to my table so that I don't forget it, and I'm going to show my unit rate, just like that. Because we're going to use that in a minute to multiply up, and I don't want you to forget it. Look at C. C says the ratios in both A and B. We have 100 over 2, and we have 50 over 1. The question is, are these two equivalent or not equivalent? And the answer is they have to be equal to each other because look, we're multiplying by 2 on both sides, and if we multiply the top and the bottom by the same thing, then they are equivalent. Now let's complete the table. D says, how can you use your answer in B? That is our unit rate. This is what we found right there. How can we use our unit rate to find the amount of distilled water to add to any given amount of solvent? Well, guys, in order for us to complete that table, we're going to use our unit rate. So let's do those in proportion form. Let's start off with 50 mils of water over 1 mil of solvent, and we're going to have to figure out how much water is going to be used with 3 mils of solvent. I'm going to have to multiply times 3. 50 times 3 is 150. So in our table, underneath the 3, we'll go 150. Now let's set up our next proportion. We have 3.5 mils of solvent, and we don't know how much water we're going to have, but we're going to make that equal to our unit rate. We're going to go from the right to the left since I wrote it backwards, and we're going to have to multiply times 3.5. When I multiply 50 times 3.5, we get 175 mils. So that's going to go right here. 175 mils of water completes that portion of the table. Then last but not least, guys, we're going to flip-flop this because we're given the amount of water we need here, but we have not been given the amount of solvent. So let's set it up the same way, but we're going to have a different blank space. Using our unit rate, we have 50 mils of water to 1 mil of solvent. Remember, our labels have to match. We're given here that I have 200 mils of water, so the 200 is going to go on top. In order to find out the solvent, we're going to have to multiply times 4. So 1 times 4 is 4. From there, guys, we're going to go to the next page. So flip now over to page 212. This talks to us about graphing with the ratios that we were just using. And I'm sorry that the red marker went through. I should have known better. Okay, guys, this says copy the table from Explore Activity 1. All we're going to do is transpose the numbers from table on 211 over here. 3 had 150 with it. 3.5 had 175. And 200 had 4. All I did is bring those numbers over. Then it says, okay, this is what I want you to do. I want you to write the information in this table as ordered pairs. Don't forget, you write your orders pairs with X value, comma, Y. And we said earlier that this is our X and this is our Y. So now we're going to look at our X and Y values and we're going to write our ordered pairs. And it tells us to do it as X coordinates being the solvent, which is what it's here, and the Y coordinates being the water. So we're going to do it just like they have it in the table. So it should be 2, 100, 3, 150, 3.5, 175, 4, 200, and 5, 250. Then it says graph the ordered pairs. When you come over here and you graph those, 2, 100, 3, 150, 3.5, 175, 4, 200, and I plot all of those points, if I get a straight edge and I connect those dots, I create a line. And it says, describe your graph. This goes through the point of origin. So this is a multiplicative relationship. Now this is kind of weird. It then says, for each ordered pair, write the ratio of the Y coordinate to the X coordinate. So for some reason they want us to flip-flop them around again. So this means 100 over 2, 150 over 3, 175 over 3.5, and 200 over 4, then 250 over 5. We know that our unit rate was 50 to 1. How are all of these related to our unit rate? The answer has to be they're all equivalent ratios. What I want to show you now, before we go on to a next sample problem that hopefully we'll have time to, I may do it on another one, is these are the steps that I need you to remember. I may have to scoot them up. Number 1, you have to write the original ratio given to you in the problem. And remember, time goes on bottom, money goes on top. Then you're going to solve for your unit rate using a proportions. And remember, unit rates have to have a 1 on bottom. Then you're going to use your unit rate multiplying up in a proportion layout to create equivalent ratios to complete whatever table you need to. Then in the table, I want you to label what is my X and my Y. Remember, X is independent and Y is dependent. Then using these X and Y values that go together as equivalent ratios, you're going to determine and write your ordered pairs. And we write ordered pairs like this. From there, using a coordinate plane, you're going to plot those ordered pairs as points and connect the dots to create a line. And some of you have had questions about this. Remember, you always do X first. You have to go in the building before you go up the elevator.